So, quick agenda for the presentation, and I'm really going to try and keep the presentation itself to around 30 minutes and leave approximately 10 minutes for questions. So we're going to go pretty quick. I'd also like to note that the presentation will be available online from our website, and then also a lot of you should have received temporary logins to our server to kind of cruise around the software. So when I'm demoing the software, one of the main things I'm going to show you is, for instance, how to create a sample device and then configure it so that you can kind of play around with making your own devices, etc. So on the agenda side, I'm going to go through just some real quick history on reasons for the software, some of the highlights in terms of features and benefits. Then we'll get down into the software's, the suite of software itself. There's the sys-tek kit, continuous commissioning, there's a client interface, and then the report writer. And all of those softwares are combined into one offering, which at the end we'll get into cost information and then ultimately questions. So throughout the software suite breakdown, I will be jumping back and forth to the software itself, giving you guys an example of what I am talking about at the time. So brief history. We were finding that paper was problematic in terms of managing documentation. So ultimately we wanted an electronic way to store data. And from that we also developed what we call automatic means of generating tests/forms for each device type that is defined in the software. Another goal was to leverage technology. This provided us consistency in our approach and advanced data analysis. We've actually been using the software since 2007 when it was first being created, and since that time it has gone through several generations, if you will, of development. Just this January, January 2013 is when we decided to make it available for purchase. Some real quick features and benefits. There's automatic test form generation. We have proven test scripts that we've been using for years that are built in to the software, and based upon configurations of devices, automatic test scripts are generated. In addition, we also use industry standard balance forms. Right now they are developed around NEB, but they will work for AABC or any other test and balance agency as well. For each step, there's what we call pass-fail evaluation. The concept behind this is to try and ensure that while a commissioning or balance tech is doing testing, that they get automatic feedback in terms of equipment performance so that they can make educated decisions on whether to pass or fail a given step. And finally, we have graphical representation of data. Each piece of equipment has a graphical representation of that piece of equipment, detailing different operating characteristics and parts, manufacturer data. And each one of those graphics is fully customizable at the end of the day to meet your needs and then also to represent you as a company. Additional features and benefits include performance-based tools, which I'll kind of show you a few of the end results of those tools when we get into the demo side of it. They're designed to analyze equipment and systems during the actual testing of the equipment. And then also there's the ability to create custom tests. So there, at any time you can make any built-in test a customized test by changing any of the text or descriptions. And then there's also the ability to make your own test using the building blocks that we utilize for the predefined tests. All right, now into the sys-tek kit, and here's where we're going to start kind of bouncing back and forth from the presentation to actual demonstration of the software. The idea behind the sys-tek kit was to manage all aspects of the commissioning and test and balance process and projects. Recently, we've been adding to that software to provide project metrics on a main screen, which will show you a % complete of different activities and overall project, and give you an estimated remaining amount of time for each, for the whole project itself. Any open issues and incomplete devices are highlighted as well for ease of management. There's also a portion of the software that's developed to provide energy analysis. We continuously get asked the question, well, how much money will I save predominantly in retro-commissioning activities? So based upon that, we have developed a pretty slick energy analysis that will give you an estimated amount of money you'll save. For instance, if you added scheduling to the building automation system for air handling units that currently ran 24 hours a day. It will give you an estimate of the amount of energy and which conversely translates into cost savings that will be incurred. There's a portion of the software for proposal generation. This is an aid to providing sample costs based upon the amount of the devices that are pre-configured into the software. We use this a lot internally to make it easier for others to get involved in the proposal generation process. There's also analytical tools. These tools are for performance, validation, and optimization, and they can be used at any time throughout a commissioning or test and balance project. Device management, this is a key portion of it. All HVAC devices and also some electrical devices as well are included under the devices tab, and this is where all testing and form management is done for given devices. There's also an area for lighting control systems. These tests are designed for networked and non-networked lighting control systems, and they fit in well with LEED requirements for testing. As well, there is an integrated test portion. These are tests that are designed to test failures, recoveries, lead lag, and in general system tests for given buildings. Then the custom tests, which we kind of talked about already, and finally issue management. So now we're going to jump over to the software. All right, so here's an example screen of the project metrics where we are looking at all the different devices that are added into the system. So it's going to give you just number of open issues, some information about the project, and then overall progress. So we can see here that this job in terms of overall progress is 98% complete. We have 3 incomplete devices out of 10, and then here we're listing our open issues. So we can at any time dive right down into that device that's incomplete and figure out what's incomplete about it. In this example, the balance forms are incomplete. There's a quick links area where we can link down to the devices, to tools, and any areas that are of help. In the project tree itself, we can see the energy analysis portion and then, for example, the proposal portion. So for this job, it estimated for these 10 devices to do commissioning and test and balance, it would be roughly $14,653. Next area we have are the tools. There are tools for doing just simple engineering calculations, conversions, psychrometric calculations. And then there's a few more advanced, real quick calculations for doing motor calcs, pumps, fans, and you'll notice that the fan and pump laws are included for these. For cooling calcs, you can do sensible cooling, total cooling, and then your water-based calculations. So there's tons of different little built-in calculations to aid personnel while they are out doing the job. Under the balance tools, we get into a little bit more advanced performance-based analysis of equipment. The coil GPM balance tool is designed to analyze coils, whether they're hot water, chilled water, DX, or electric, and natural gas. Whatever type of coil you have, you can configure and set up in the configuration screen and then analyze that given piece of equipment's operation. There's some for outside air, fans, chilled water systems, pumps. So as you can see, we've got tons of different performance-based tools that are built in as well. The monitoring kits area is designed to work with a hardware platform that we also provide, and basically turns the software into a big data logger for the ability to monitor a full air handling unit with standalone data logging, just as an example. Now under devices, this is really where a lot of the benefits of the software come to fruition. We have broken out the different subsets to make it easy for navigation. So for instance, all your air handling unit types of equipment are listed here. All devices are listed here, and since there's only 10, it's not an overly large database. For each device, you have metrics for that device as well. So it's just going to give you some quick feedback on FIV, stand for Field Installation Verification. So all those have been complete. Function performance tests were complete, and there were, in the design checks, some areas of failure under the chill water coil design validation. So just giving you some quick feedback in terms of that information, and also overall % of your testing that is complete. Down below here is our snapshots, and these are derived from the performance-based tools that we were discussing up above. So for this example, we've got a chill water coil analysis from the balance report that we have done. So in this example, the tool was utilized, and then the information was saved down to the device to validate the performance of the system while the balancer was doing its job. So it's used it can be used to check test and balance information as well as just overall performance. So here's another example of testing that was done on this coil when we were doing commissioning. So, and all these are utilizing measurements either from the test and balance reports, from the building automation system, or handheld devices such as like a thermal hygrometer for measuring temperature and humidity. Here's an example of the outside air calculation that was performed to verify the percentage of outside air that was being brought in. So in this example, we calculated about 26%, and the measured CFM was 39%. So this is just trying to give an idea of the performance of the outside air or the economizer section. You'll note that also incomplete tests are highlighted here as well. So if we go to, if there's a device that has any incomplete tests, they will show up in that spot. So what we're going to do is we are going to come down, and you'll notice in the functional performance tests that the status and then the estimated duration for those tests to be performed is also calculated. But we can at any time add in an additional test. So we're going to add in, let's see, what test do we want to add in? We'll just add in a HU cooling check. So sample, and here's where you can give it a name and hit OK. So once it's added in, then we can set up the test, and we'll just provide some brief information about it. So we're going to say it's a DX coil with one stage. The first stage is a digital scroll, and it's going to control the supply air or space. We'll select space and hit OK. And now that information is generated and provided for that test. And then if we come back, we can see that our test is incomplete, and it's estimating 28 minutes to perform that test. So, other areas of note are, for example, on air handling units, there's an IAQ calculator that's provided, and it's based upon ASHRAE 62, and it's designed to calculate the minimum amount of outside air or ventilation air that's to be brought into a given space that's associated with an air handling unit. So we utilize this a lot in retro commissioning, and then also in new building commissioning to confirm that the design is bringing in the proper amount of minimum ventilation. And then also in terms of retro commissioning, we find several areas of savings in terms of being able to reduce indoor air, outside air being brought in for ventilation purposes. Other items are each device has what we call a printout, and the printout, this goes back to the graphical representation of data as well. It's designed as a one-stop shop for the maintenance personnel in terms of being able to find out all information about a given device. In this example, we put all the filter information, all the fan motor information, coil information for the heating and cooling, and also in this example, the exhaust fan information. These are fully customizable, and as part of the training, we show you how to customize these graphics to fit your company and also your needs. You can add in various other readings from testing that you've done to these printouts. Air handling units are the only ones that do not come with a predefined printout. If we go to a VAD box, these will have printouts that are designed for them. Oh, got a broken wing. So let's go back into this one. So this example has a dual duct box, and all the information that was gathered for testing and then also for maintenance personnel is provided in that area. Also, for balancing purposes, we have pressure profiles that are provided and then also printouts as well. In terms of balance forms, we have an overall balance forms view and then also individual balance forms. So in this example, this is for an air apparatus form for an air handling unit. So all the information that's provided for that air handling unit is housed on this form. In this example, we were only doing balancing, whereas in Air Handling Unit 1, we were just doing commissioning. So you can see that the software can be utilized for either balancing or commissioning activities. Under several of the tests, there are what we call advanced performance-based steps. In this example, this is for a chiller, and information that is provided and plugged in, usually for the chiller, we'll get this information strictly right off the chiller control panel, and then also from local gauges or our calibrated testing equipment. So in this example, we're putting in design and measured evaporator pressure drops, design GPMs, measured chilled water supply and return, design tons, percent load off the chiller control panel, and then condenser water information as well, and integrated part load values. And from all that information, we will calculate operating KW and then what we call the calculated KW. So one of these is looking at the information provided from the chiller control panel. The other is calculating based upon calculated tons, which in this example ended up being 540. So there are several different advanced steps that are provided throughout. And at any time when you're doing testing, you can turn these into a snapshot, which is going to come back up and utilize this tool to plug in the information and ultimately provide you with a performance snapshot of the chilled water system. So in this example, it's the very example we were just looking at, we can see that also cooling tower information and performance is analyzed as well by entering in condenser water temperatures and then also entering and leaving temperatures and humidities from the tower. Calculations are run to determine evaporation rate, your actual approach temperature, and then your makeup water GPM at that given time. So as you can see, there's several different devices and device types throughout. There are over 42 different device types. In this example here, this is a water source heat pump, just as another one of the device types. Yet again, sticking with the mantra of trying to put all the information that would be required by the facilities personnel onto one given sheet of paper. Then we come down into the lighting. In this example, there are no lighting devices added, but we can add a lighting room, which is just basically an office or whatever the case may be. And so we can add a lighting room in. And then we can, to that room, we can add in different standalone lighting devices, if you will, like a standard light switch or an occupancy sensor. So when those devices are added in, ultimately tests are generated for each of the device types. Under customs, in this example, I have 2 sample custom tests that we have created. And at any time you can add a custom test. You can use a standard test as a base and modify a base test, or you can just start from scratch and make your own test using, yet again, the building blocks that we have utilized for our testing purposes. So if we're up under a device and we want to add in one of our custom tests, there's a Configure Custom Test button checkbox, and when you check that, you now have the ability to add in custom tests. So it will go down and find all the custom tests that are under the customs category, and you can select that one and add in a test at any time. So now that test is incorporated into Chiller 1's functional performance test as an example. Issue log, that's another big item of interest, if you will. With issue logs, all issues are stored under here, and when at any time you're in a test, you can add an issue from any step. You can make an issue, or you can add in testing notes about the step. So in this example, we can add in issue for webinar. So you can add in details, and then you can hit the Make Issue button, and from there you can give it a title, a location, mechanical room, who found it, and who it's assigned to. So we'll say it's assigned to the mechanical contractor. Now if we come back over to our issue log, we will see our new issue in here, and we can drill down and add in different information in terms of more information about issues. And ultimately, we can also enter in what the resolution was at the end of the day. And from each one of these, we can add these issues to an observation report, or we can ultimately just export out the issue log itself. So there's also a category for design issue logs that are found during the design phase of the review process that can be added into there. There's an area for reports, which we just kind of highlighted briefly. You can store meeting minutes and then ultimately create to-do lists. So now we're going to jump back into the presentation. And the next subset of the software suite is what we call continuous commissioning. Under the continuous commissioning, this is a solution that utilizes both software and hardware to integrate in building automation systems and then analyze the information that is gathered from those systems. This is commonly utilized for lead measurement and verification, and then also we utilize it in retro commissioning, where we'll launch one of these kits at a building, pull in the building automation system information, and then start analyzing and trending that information a few months or a few weeks before we even start our retro commissioning activities, in an effort to learn as much about the systems that are being retro commissioned as possible, and then also fine-tune what we are going to accomplish and focus on during the retro commissioning process. The continuous commissioning solution is built around Tritium Niagara X software and hardware. Also important to note that the sys-tek kit as well is developed on the Tritium Niagara X platform. So it encompasses all the built-in software features of the Tritium solution, as well as the enhancements that we have provided in the software. Continuous commissioning kits are dynamically trending data that is selected by the user for trending, also performing automatic data analysis for calculations and fault diagnostics. So we're calculating, as an example, chilled water tons being utilized by an air handling unit, and then also analyzing the performance of control algorithms for that chilled water coil on the air handling unit. As issues arise, messages are recorded in the CX commissioning software that is then able to be reviewed and analyzed to see what potentially could have been causing the problem. In addition, there's also an energy dashboard just for quick hitter information. So I'm going to jump back in and just show a sample continuous commissioning or measurement and verification project that we have. You'll note that all the tools that were available in the sys-tek kit subset are also available for use in the measurement and verification continuous commissioning kit as well. What we've done is broken up the different subsets of a building into different components. So for building devices, we'll have power monitoring, power meters, and BTU meters are stored under here, so we can drill down into each power monitor. And we'll notice that there's points associated with each device. These points are inputs, meaning they are coming from an integration of a power monitor or from a building automation system. So if they're inputs, they're just coming in and being analyzed. Whereas if we come to an airside device, like Air Handling Unit 1, we will have analog points that are inputs, set points, which are coming from the building automation system, and then outputs, these outputs are calculations or output parameters that are calculated by the software based upon information that is being measured. So in this example, there's also digital points for supply fan command and then status, or we're continuously watching the command versus the status and creating alarms and flags based upon comparing those two values as an example. You also notice that we have what we call pieces of energy. These are supply fans, economizer, cooling coil, heating coil, anything that utilizes or generates energy is stored up above and then continuously monitored. Chilled water devices are broken up as well. So in this example, there's an air-cooled chiller, and so we're watching GPM and we're calculating in this example tons and kW continuously based upon GPM and entering and leaving temperatures of the chiller, and then also with integrated part load values that we have stored into the chiller itself. Conversely, on hot water devices, so you can see the trend. And then here is just a real quick energy dashboard, so it's going to show outside air temp and humidity, and then it's going to show you your air side total. So it's calculating fan energy, energy used by the chilled water coils, hot water coils, DX coils. It's calculating and summing up your amount of supply air, and then also the amount of outside air that's being brought in at any time, and then cooling and heating tons and BTUs at a given time. Same thing with the chilled water and hot water, heating hot water plants. The next portion of it is what we call the client interface, and this is web-based access. So clients or contractors, whoever's wanting to access this interface, are not required to have a copy of the software. The software itself will run on a server. For instance, we have a copy running on our server, which when you log into the sample, that's what you're logging into. So we set up a client interface in a similar fashion where our clients or contractors or whoever's involved with a project, whether it's ongoing or it's been done for a couple of years, can log in and access all the information for commissioning and test and balance, all through the web. All testing information is managed on a per client basis. So each client has their own section, and under that we store their buildings with that, all the building information. The other portion of it is all the users are managed and created by you. So you can dictate the amount of rights that a given user has. So let's say you're wanting a mechanical contractor to view the issue log. You can make it so that he can only see his issues, or and you can make it so he can either comment on the issues or resolve an issue or just look at it. So you have the capability to really customize that experience for whomever you're allowing to access your systems. So as a real quick example, we have a CX project holder, and under that we've got the University of Missouri Kansas City, who we've done a few buildings for. So we can drill down and you'll see that a lot of the subsets that are from this package are also provided down below. So access to the tools is provided. Actual devices that were tested at this time are provided. So if we come in, we can look and see that in this example, the balance forms were not yet completed, so we have not patched those devices yet. We can drill down and look at the actual functional performance testing that was done. So in this example, the chilled water valve was tested and passed on the 10th of September, 2010. Different fan coil units, etc., are provided. The other side of it is there's the ability for the clients to recreate the functional performance tests that are stored up here. They can recreate those blank with all the pertinent design information stored in them already, so that they can rerun tests if they want. Same thing with balance forms. They can regenerate all the balance forms that are stored up here blank in terms of the test or the actual data, but still keeping the design data that was already previously recorded in terms of the fans, etc. So this gives them the ability to go back and either retest on their own, or let's say you are lucky enough to every 6 months come back and fine-tune their systems. You can use this as a spot to rebuild your tests without having to start from scratch. So as you can see, we've got several different buildings that we've done, and when they would log in, and it would automatically just point them to the University of Missouri, Kansas City, where they could see only their buildings and no other clients' information. The report writer is designed to basically take all the exports that are dumped out of the software, and they are exported out as what we call a CSV file. The report writer runs over the top of those and turns them into nice-looking Excel workbooks, and from there we can PDF, manage the data, etc. All of the printouts are customizable to reflect your company in terms of you can put your logo in there, you can change colors from the templates, and really customize the look and feel of that aspect of it. Now we'll get into cost real quick. The first copy that your office buys, whether you have 30 offices or not, the very first copy for your company, if you will, is $1,500. Every copy after that is $750. For each one of those copies, there's an annual license renewal for that very first copy of $1,000, and for each additional copy, there is a charge of $500. For the continuous commissioning solutions, we have standard kits that you can buy that are developed to access LAN workspace systems, BACnet, and Modbus-based automation systems or power monitoring systems, whatever the application may be. The nice part of the Tritium side of it is we also have access to proprietary software protocols, for example, like Johnson Controls N2 protocol or Carrier's Comfort Network. So we can provide software drivers for those as well. These are what we call open protocols, so they're kind of the standard ones. So we have pricing just for those on the website, but if you need a custom solution, we can work with you on that aspect of it as well and come up with some of the additional costs for the software drivers for those. So, all right, now I'm going to look and see if there's any questions. Let's see if I can find where questions might be. We have 2 questions. Okay, let's see. Question, you mentioned the performance modeling from the hardware device that you provide that functions as a data logger. Can the software process data imported from a BMS running trend logs? Let's see. Imported, not necessarily. For that, what we would do is we would integrate in the building automation system and then analyze their data in that fashion. Right now, there is no functionality to import into the software from a building automation system trend log. However, that's a really cool idea. That's one part of the software that we haven't really touched on is in, what I call the organic nature of the software. Each user, as part of the licensing agreement, can request and make recommendations for software upgrades. For example, working with a company in San Diego right now who has a unique application of a heat pump, and we are modeling and creating a new device to meet that need. Once that device is created, it now becomes available to all users of the software in terms of an update. So we really encourage and request recommendations and requests for enhancements because that just makes the software better for everybody. So right now in that instance, what we would do is probably integrate in the building automation system and pull data from it, and using the continuous commissioning aspect of it. You can also set up the measurement and the monitoring kit to integrate as well if you just want to just grab data and trend it and not necessarily analyze and run calculations. So next question. Can outside provider tab information be imported in the system to be included in the final report? Not automatically. Just from a software aspect, the importing of data from Excel is somewhat difficult in terms of you have to have a set way of importing that data. For instance, I'd have to say supplier CFM is always in Excel cell A1. So one of the things that we're working on right now is building custom importers where you as the user can say, all right, I want to import this information. Here's the cells that I want to import, and here's what it reflects, and connect it to this balance form. Right now, what we do in those instances is we manually type in the information. While it seems like an arduous process, which it can be to some degree, we like to have all the information that we can electronically, especially for the client side of the interface. While we do provide commissioning and test and balance, there are several instances where we do not get to provide both for a given client. However, we like to have as much of that information still available to them through our web interface. Okay. You know that the system has 40 plus devices already in the program. Can we add more or customize? Yes and yes. That kind of goes back to my earlier response in terms of the organic nature of the software. Providing us with that information, we can model the device and add it in and incorporate it in to the software, or there is the ability to add in a generic device, and from that you can add in your own tests and make your own device in that fashion. However, if it's a one-off, that's a viable solution, and we do that all the time for just something that we never think we'll see again. However, if it's something that you're going to run into on a continuous basis, then I would recommend giving us that information. We would add it in to the back end of the software and then provide an update, and now it'll be incorporated in just like every other device. So in that instance, now we would have, let's say, 43 devices instead of 42. In commissioning systems, a paper copy is typically used to brief equipment and controls contractors. How do you prepare a paper copy? What we do with that is in the software itself, there's the ability to say, I want to export this as a commissioning plan. So when we do that, it exports it out, and instead of filling in testing information or blanks, it will actually just provide a underline after a given reading or request in the software to where people can manually fill out that information. So we'll export it out, run the report writer on it, and now we have an Excel spreadsheet that we can either PDF and print out or just print out and give to a contractor to fill in, and then we would go back in and put in the actual data gathered in that fashion, so in the software. Because ultimately what we want to have is an electronic copy of that information, whether it's gathered and written down, or as we're testing, we're entering the information in. It just depends upon the job. Sometimes you're up in a mezzanine and getting a laptop or an electronic piece of equipment up there is not practical. So we will fill out some stuff on paper, bring it down, and then get it into the software. So as soon as we can get it in the software, the better, because then it is stored and backed up on servers and all kinds of good stuff. You mentioned the performance modeling from the hardware device that you provide that functions as a data logger. Can the software process that? Oh, that was a repeat. So I think I kind of covered that aspect of it as well. In terms of the monitoring kits, we provide a hardware solution and the software solution as well if you want to utilize just as a data logger the functionality. For instance, we'll provide you with sensors with cables and Molex connectors. We use this a lot for analyzing chill water systems. We have a kit that's designed to analyze the performance of a chiller, for instance, where it has a built-in wet-to-wet differential pressure transmitter and immersion type sensors that actually slide right into Pete's plugs, and based upon that information we store that and hook it up to our monitoring kit, and now we're starting to trend and log that information continuously and not relying upon like the building automation system for that information. We're just getting it locally ourselves, and sometimes that's at a chiller, sometimes that's at a spot in a distribution system of piping. So it's just really dependent upon how you want to use it, but they're just sensors, temperature, humidity, pressure, all the different sensors that you can think of are provided and then can be hooked right into the monitoring kit itself. All right. Well, we did pretty good there. Unless there's any other questions, we made it in about 43 and a half minutes, so that worked out well. I wanted to keep it under 40 minutes. That way everybody had an opportunity to maybe do it during lunch and not have your whole lunch taken from you. So, having said that, if there are any additional questions, by all means, you can go to our website, www.sys-tek.com. That's sys-tek.com. You can call area code 816-229-9009, or you can email info@sys-tek.com. That, or you have probably my email or Rebecca's or Ashley's from our office. Feel free to send any of those questions our way. Real quick, before we get done here, I wanted to show an example of adding a device now that I think about it. That way, if you're playing with the software through your login, you can add a device and configure it and you know, kind of have free will, if you will. So we're going to go, we click the Add to Device button there, and we'll say Sample. And here's where we can select from those predefined devices. You'll see that there's dehumidification, air handling units. Anything that we've run across is in here, from medical gas systems, dental vacuum systems, alarm systems, refrigeration pump systems for in-row cooling of server racks. There's just tons of different stuff, variable refrigerant flow. So what we will do is we're just going to kind of keep it simple, and we'll add in a rooftop unit. Here's where you can define what you're going to be doing on the project. So we'll say, yeah, we're going to do balancing FIVs and FPTs. So when I hit the refresh button, we'll notice that now our sample is also there and there. These are several different ways you can browse. You can also find it over here in the tree and browse to it. So now the next thing we need to do is configure it. You'll notice this checkbox that says Configure Device. When we click that, now we can come through and provide some information about the device itself. So for this example, we're going to say it's a constant volume supply fan. It's got DX cooling. We'll say it's 2 stages. The first stage, yet again, we'll say is a digital or modulating scroll compressor. I live in the Midwest, so we're going to give it some preheat. We'll say it's natural gas. And then just a standard mixing section for the economizer. You'll see there's several different options for that. No freeze stat. We'll say no high pressure switch, but it is BAS controlled in this example, and there's no manual switch for control. That would be like an HOA or something on the wall to turn it on and off. So we'll hit OK, and now once we've configured it, it'll let us know that we've configured, and then we can browse and we can look at balance forms that were predefined and provided based upon our selection of equipment. The little home icon will always take you back to the device. So in this example, here's the field installation verifications that were provided. So these are the ones that we would export out and give to a contractor. These are pre-commissioning or pre-functional tests is another name for them. Just verifying that everything's installed and ready for functional performance testing. Then our functional performance tests are provided based upon our configuration. So we'll notice that there's a DX coil check, and since we had 2 coils, it'll verify the operation of both coils. That's the idea behind the test. I always say on these tests you're going to get about 90% of what you need, and that other 10% is some engineer's idea of how to test or how to operate a piece of equipment. So there are unique sequences, and that's where our custom tests come into play and the ability to create those tests. All right. Well, I went over a little bit. I apologize for that, but I did want to show everybody that. And if you did not receive a login for accessing the software on our server to tool around and check it out, please let us know right away, and we will get that set up for you. Thank you, everyone, and we will talk to you later.